Welcome to 7.3 day 3, which is the volume of a region revolving about a line that is not an axis. We are going to talk today about lines, revolving about lines that are parallel with the x-axis. The first one we're going to start with is revolving about the line y equals -2. We've talked about revolving around the x-axis and revolving an area about the y-axis. Now we're going to revolve about other lines, not just the x or y axis. The first one we're going to start out with, like I said, is y equals -2. We have a region bounded by y equals 1 over x, which I have drawn on the graph, and the x-axis. So the green lines indicate the area. We are going to revolve around this line, y equals -2. And they've given us easy boundaries here where x equals 1 and x equals e. So those are our two limits of integration. Now, what we need to do is, this is going to be a washer cross-sectional area where the area is going around y equals -2. So we are going to have an outside radius and an inside radius. So our volume equation is going to look like this. The integral from 1 to e, they made it easy for us by giving us those two x values. And we have the big R squared minus the little r squared dx. So let's take a look at what is our big R. Our big R is going from our curve all the way down to -2. So we calculate that big R by, remember we subtract top to bottom to get the areas. So we have 1 over x minus -2. That is going to be equal to our big R. Our little r is going from the, this line, going from our x equals, or actually y equals 0 line down to y equals -2. So our little r is going to be 0 minus -2. So those are going to be our big R and our little r. We're going to subtract them and square them. So our volume equation, sometimes these equations are just asked to be written out, like write the integral equation that would solve this, and sometimes you actually have to put them in your calculator and solve them, and sometimes you have to solve them manually. So you need to be prepared to do any of those three things. We're going to go from 1 to e of r squared minus r squared. So taking into account these two r's, we have 1 over x minus or plus 2 squared minus r equals 0 minus -2. This equals a +2. So minus 2 squared. Put this all in a big bracket, r squared minus r squared times dx. If you put that into your calculator, you will actually get the number 14.552. Don't forget to put the pi in when you do that. Or if you're asked to just write the integral equation, that would be your actual expression. All right, let's look at another one, which is also a washer. This one's a little more complicated because, let me move my recording button here so you can see it. This is a little teeny bit more complicated only because we have two regions that we have to section off, and we're going to have to find the two intersection points of these, which can be done fairly easily on your calculator. And so the first thing you need to do is draw these two. I have already drawn them. Make sure that you can do this on your calculator. Also draw the line we're revolving about the line y equals 4. So this time our line is above our curves, so our r's are going to be a little bit different, and we'll look at that in just a moment. Let's figure out what a and b are first. And this is really a calculator problem. So you would just put the two y values into the y equals in your calculator and do second trace number 5, which gives you the intersection. Second trace number 5. When you do that with these two equations, you find that the number for A is, and this is the way you should write it on the AP test as well. Write down A, and you could use any variables for these, but write down A equals whatever number it is, and B equals whatever number it is, 3.7071068. Make sure that you're able to get those two numbers. It's important to be able to do that. So check that those are correct and what you get. Next, so we have those two. So what we're going to do is, because part of this integral from 0 to A, the cubic function is on top, and from A to B, the line is on top. So what we're going to do is divide these two regions in half, and we're going to take the volume equals pi times the washer going from 0 to A, so we have to take r squared minus r squared dx. And then we're going to add to that the second area, which is pi times A to B of another r squared minus r squared dx. All right, that's our basic general setup. We need to figure out what r and r are. That's a lot of r's. So volume between, for the first one, what we're going to measure is we're going to measure the radius between the 4 line, y equals 4, down to the line. So this big R is equal to, big R, for this, I should actually write this in green. This is our green function. So for our little green function, the big R equals 4 minus x over 2. The little r equals the y equals 4 line down to the cubic function. So equals 4 minus x cubed and 6x squared plus 9x. That's your big R and your little r, which you're going to plug into the green part of the equation. For the red part of the equation, we have a big R that goes from 4 all the way down to the cubic function. So 4 minus the cubic function, that's the big R in the red part of the equation. And then the little r is going to be equal to 4 minus the line, which is x over 2. All right, in order to find the actual answer, you're going to need to plug these in and take the antiderivative with respect to x. So I'm going to write these out just so you get an idea of what this equation should look like. Volume equals, let's look at the first area over here, the larger area where the cubic is on top. Pi going from 0 to A of, big R squared, 4 minus x squared squared, and subtracting that little r. I'm not simplifying this at all. 4 minus x cubed. And that also needs to be squared, all taken with respect to x. So that would be the first part of the area. Then we would add the second part of the area, which would be pi from A to B. So this time we have the cubic function on the bottom, so the big R is going from 4 minus x cubed. And we need to square that, subtract the little r in this equation, which is 4 minus x squared. x. All right, if we add those two together, that would give us our equation. And what you should get, if you put that into your calculators, you should get 95.106. 106. So test that out. But often in this type of equation, they would just have you write the setup and not actually have to calculate the number. But it is possible. But they like to have, it makes it easier to write, by the way, if you change the intersection points to two variables. They don't have to be A and B. It really could be any variable that you wanted to write with that. So you don't always have to go with A and B like I did. Okay, so this is your complete answer. And that's all. That's going around lines that are parallel with the x-axis. The same thing would be true if we did lines that were parallel with the y-axis, except everything would have to be written with respect to y. All right, signing out, except for these are your assignment problems. We do have a little handout with 4 good, juicy problems on it that you will get to solve. So, signing out from day 3, we have one more day of volumes and one more lesson in this class. Usually